Hello, in this screencast we're going to walk through the process of taking what is called a t-test. And a t-test is used, it is basically the same process as the z-test we did in the last chapter, but it's under what is really probably the more actual setup of where you do not have a very large sample and you also do not actually know what the standard deviation of the population is. The last chapter walked us through the process of conducting a z-test and the hypothesis test process, but it was somewhat in a fictitious state. And in this chapter now is the first of many coming up that are going to be focusing on more actual scenarios. And the scenario here, we're going to walk through the items of 13.2 and 13.3, which were progress check items in chapter 13. So these are problems that are already done in the book, but I would find it helpful to kind of walk through the whole process in one step rather than broken up throughout the chapter. Um, so the hypothesis in this situation was they were checking the weight of the amount of beef in a packaging of packages that stated that it was 1 pound of beef. And the test being conducted here is to test to see if the company was cheating out in the packages and actually packaging less than or significantly less than 16 ounces of beef. So our alternative hypothesis is that the actual true mean is less than 16, since we're comparing to the 1 pound or 16 ounces on the label. And that, therefore, then it leaves our null hypothesis, which is the complement of that, to be that the mean is either greater than or equal to 16. The fact that we're focused right here on an alternative hypothesis that we're checking to see if the packages are false and that there's actually less than 1 pound of beef signifies that this is a one-tailed test. So we're going to take a look at a normal curve here of all the samples of beef possible of these packages, and 16 we expect to be the mean, and sometimes you are going to get a little bit higher and a little bit lower. But for this problem here, we're testing a one-tailed test down on the lower end or in the negative end, such that if our sample ends up down below here in this tail, then we're going to make the determination to reject the null hypothesis and say that there is a statistically significant difference here. So, but how do we do that? First thing we need to do is find the mean and the sample standard deviation. In this case here, um, I went through and did it on Excel. And I recommend you take a look at the screencast that walks you how to do this. But basically, instead of me doing this by hand, I put the 10 different samples in here on one column. And I used our data analysis tool pack and found the descriptive statistics. And it produced a mean of 14.7 and a standard deviation of 0.82. And we're going to use that as our sample standard deviation. The sample size was 10. And what we also need to run our test is what's called the standard error. So the standard error, if you recall, is this standard deviation divided by the square root of the sample size. So if we take 0.82 and divide it by the square root of 10, we get a standard error of 0.26. You can also get that right here. If you notice it also gives you that. So we have most of the background data we need right now to conduct the test. Then we have to take a look at what is our critical value. And our critical value is on this normal curve. In the last chapter we used z-scores. What is the z-score that is our make or break point or our critical z-score? Such that if our test provides a z-score beyond that critical z-score, then we reject the null hypothesis. In this chapter, we're focusing on what are called t-distributions or t-scores. And a t-distribution is much like the normal curve. However, due to the fact that many times you have sample sizes that are small, then we need to have a little bit more leeway and a margin of error here. And the textbook goes into detail with that. But the key thing to note is that we are not using the table in the back of the book of the normal curve to find a critical z-score. Instead, we are going to page 460, and on page 460 is another table that is the table of t for the t distribution and t values. And the key processes you have to do in order to find the critical t-score, which again is this make or break point right here, is in the back of the book. You have to first see whether it's a one-tail or two-tail test, because there's two different sections of this table. From this alternative hypothesis, we see that it is a one-tailed test because it's just less than. If it was not equal to, then it would be a two-tailed test. So since it's a one-tailed test, I look in the page 460 in the section of the one-tailed test. And then I know from the problem it says that it's a 95% confidence level or an alpha of 0.05. So since our alpha is 0.05, we look in the column under 0.05 for one-tailed tests. And then we go down to what's called our degree of freedom. This was mentioned way back in chapter 4, but basically the degrees of freedom is one less than the sample size. So since 10 was the sample size, I subtract 1 from it, and I get degrees of freedom of 9. So on that table, again, I identify it's a one-tailed test. I go under the column for the alpha of 0.05, and I go down to the row that has a degree of freedom of 9. And it gives me a value of 1.83. Since the t-distribution, much like the normal curve, is symmetrical, it is giving you values just for the positive end. All right, but realize that since we're dealing with a less than here in our one-tailed test, we're looking for a value down here. We then just take the negative of that critical t value. So, key thing we have to do now is compare the t-score that we get from our data from our sample and compare it to our critical t. If our t-score ends up being further out in the tail than our critical t, then we are going to reject the null hypothesis. If it does not go as far as negative 1.83, say for example it comes out to negative 1.0, then we retain the null hypothesis. It wouldn't be that far out. Last step now is to take a look and actually find our t-score. So our t-score is our location on our normal curve, or in this case the t-distribution curve, and that tells us where we are based on our sample. So we take our sample mean and subtract from it the population mean. The population mean comes from your null hypothesis. It's supposed that these packages are all 1 pound or 16 ounces. So that is what our supposed population mean is. So that is our mu. So we subtract 14.7, which was our sample mean, minus 16. That tells us how far away we were from the mean, and it's a negative value since we are below the mean. And we divide that by the standard error of the mean, which was 0.26. That was found either here through this formula, or you can get it right here, the standard error, from the calculation of the descriptive statistics. That yields a t-score of negative 5.0. So that means that if our critical value here was negative 1.83, and our 0 would be right here at the mean, a negative 5 is way out on the tail, way beyond that critical value. Therefore, then we reject the null hypothesis. And we state that data shows that the packages are have less than 16 ounces of beef in them on average. Thank you.